before I start, has anyone already heard of Docling? Has anyone? Okay, awesome. Okay. Also good there's not that many hands. Okay, so today I'll be talking to you guys about Docling. So what is Docling? Docling is an open source project. It's a Python library. And the primary goal of Docling is to help you convert documents of various formats, including PDF, DocX, Excel documents, PowerPoint documents, HTML documents, etc., into more AI-ready formats. So I imagine a lot of you either work in or want to work in or have at least experience with working in some sort of AI application, right? So building AI applications, using AI applications, whatever it is, any sort of AI application requires data to be in a very specific format to be used correctly, right? So a lot of AI applications, specifically for training data, require markdown format, right, or HTML format, some data format that's very easy for an LLM to parse. That being said, right, most of the times with your own individual documents or organizational documents, they aren't going to be in those standard pretty formats that are, quote, AI ready, right? You're going to have a lot of scanned documents, you're going to have PDF documents, PowerPoints, all these documents that you want to be able to use in your AI applications, but you can't use them effectively because it's very difficult to convert those into those AI ready formats. So Docling does that for you, right? It also incorporates that advanced PDF understanding. It also includes page layout, reading order, table structure, code formula, and image classification. All of these advanced understanding pieces make the data that you're converting more valuable than just stripping the text, right? All of those data pieces are then converted into the Docling document format, which is an HTML format, which can then be exported into those various AI-ready formats like Markdown, HTML, and JSON formats. It's also, all the models that are used in Docling are obviously open source, but they're also very lightweight, so you can run them locally. All the models that we use today can be run on your laptop with reasonable inferencing times. There's a lot of integrations with other AI development platforms like LangChain, LlamaIndex, etc. There's OCR support, there's visual language model support, and there's a very simple and convenient CLI. That URL there is going to take you to the actual official Docling GitHub repo. But why is it that we actually need to use Docling, right? Like, why can't we just use some of the more simple tools that are out there that are built to just strip text out of the documents that we have? This is an example that we like to use as to why it's important to have more advanced structural understanding of documents. So as you can see here, in a very simple two-column scientific format, this phrase vegetative electron microscopy appeared, right? And it started being cited in all of these papers, right? Peer-reviewed, published scientific research papers. This phrase vegetative electron microscopy just started popping up in these journals, right? No one actually knew where it came from. No one really knew what it meant. But when people started digging into it, they found out that in an article from 1959, the term vegetative and the phrase electron microscopy actually spans two columns in a document, right? So in this very simple two-column structure, simple text parsing was not able to actually understand that those are two separate words, and it merged those two words, and it led to all these embarrassing citations for a word or a phrase that did not actually exist, right? With Docling, or at least with some more advanced structural understanding, you can see that vegetative is going to be separate from electron microscopy, right? So even this type of structural understanding can affect how valuable your data is. It can affect the semantic meaning of the text that you're extracting. And once again, by using Docling, you're going to get more valuable data from the data that you're converting. When we look at some other low-level PDF parsers, right, you can see when you convert them, you're losing a ton of information out of your data. A lot of the page headers are going to be left in random text places, right? The tables aren't going to be understood correctly. You're just going to be stripping numbers out of the tables. Image content is going to be missing. The line wraps, again, that two-column format is not going to be well understood. Those multi-column formats will also break the reading order. If you look at what Dockling's able to do, right, so using that advanced structural understanding, but also table understanding, image recognition, all of that great stuff, Dockling's able to convert the document into a well-rendered HTML, right? And here we actually have the table not only rendered correctly, but also the merged cells rendered correctly, right? So Dockling is capable of recognizing table structure and preserving table structure in its conversion. There's actually three main pipelines that Docling uses for document conversion. In the first slide that we have, it's going to focus specifically on the conversion piece of Docling, which really is the most important piece of Docling, right? But there's three pipelines that Docling actually uses for the conversion. There's a simple pipeline, which makes a lot of sense. It's a simple pipeline that parses documents that are very easily parsable, right? Usually those markdown formats, those doc formats, PowerPoint, Excel formats, all these formats where you can simply parse text out of them. The structure is relatively easily preserved. You can use a simple pipeline with Docling. The PDF pipeline is going to be a little more advanced, so depending on what type of PDF you have, there are some PDFs that are still very easily parsable, but then you also have PDFs that are scanned PDFs, right, which are going to be more like images. There's a specific pipeline for that, and within that pipeline, there are actually various models you can enable or disable. You can enable OCR, you can enable table form models, you can enable layout analysis models. All these models you can turn on and off within that pipeline. Again, all of it is just to convert that pipeline, convert that document into your Docling document format, which you can then export into all the various formats. The last pipeline and the newest pipeline is going to be the VLM pipeline, so Visual Language Model pipeline. It's taking a fine-tuned visual language model, which allows you to upload an image of any document, right? So technically it's format agnostic because it can just be a scan of any type of document. You upload that document to the visual language model, and it converts it directly into that Docling document format, which again you can work with in the way that you can work with the Docling document format, right? You can export it into those various different export files. You can create data sets, chunking, etc. The visual language model that Docling uses right now, or the most updated one, is actually only 258 million parameters. So if you have a sort of understanding of the scale of models today, 258 million, very, very small. Very efficient, right? So in terms of processing like lots of scanned documents, it tends to be a better choice than the majority of those larger VLMs that exist. Okay, great. So I've gone through a quick overview of Docling. Are there any questions about Docling as a whole before we move into the labs? Not seeing. Oh, one question.
What is like the end-to-end like processing time maybe for some of the examples? Like obviously probably depends on the file size, but
yeah, it depends on the file size, but it also is going to depend on what models you're enabling within those pipelines, right? So the PDF pipeline is going to be the most commonly used pipeline, just because most people want to use Docling for PDFs. If you enable OCR versus disable OCR, that's going to be like the biggest time shift in terms of the amount of time processing. Usually with just like a simple PDF, it's like a couple seconds on like a laptop, right? With a scanned document, it may take like 10, 15 seconds per page, but it largely depends on what complexity the document itself is. And I don't mean complexity in terms of the amount of text on it, I just mean complexity in terms of whether or not it needs OCR or whether or not it has tables in it. Yep.
Does this also work with encrypted PDFs?
Encrypted PDFs. Honestly, I'm not 100% sure, but in our lab today, we will be going through conversion, so if you want to upload your own encrypted PDF and try it out, you can see if it does work.
How does it compare with existing methods provided by APIs, like Mistral provides a PDF, page parser?
Yeah, so that's a good question.
99 point something.
Yeah. So performance of these kinds of things is a little bit difficult to verify because when you look at like a PDF, like how can you determine what the ground truth structure is without using a conversion method, right? So one thing that the Docling team is working on is building out a data set that would be a good reference point for those conversions. If you go to the Docling paper itself, it actually does have some like fine scores between like different types of conversion, like code recognition, table recognition, that kind of thing. So you can check out the actual Docling paper, which I will have a link to actually in the lab itself. But yeah, if you guys go to that QR code /link, you can pull up the lab and we can get started on lab 1.
Quick question, so the VLM, is that like an open source model?
Yes, it's on Hugging Face. If you just look at Granite Docling, you'll find it, and there's also a demo space available. You can upload your own documents too. Yep. Okay, so if you have that link now, what you should be opening will look something like, well, whoops, don't look at that. What will it look like? Just do Docling workshop. Should look something like this, and then you can click on this workshop tab. There's pre-work that you can do. But lab 1, I would recommend just opening it up in Colab. You can do it in GitHub as well. It just may take varying download times. But if you click on the open in Colab, you'll open in Colab. I actually already have it all run on my local device because I did not want to risk Colab crapping out on me. So everything is run here. I can go through it with you guys slowly if that's what you want. I'm not really sure what people prefer in these sessions. Do you want me to walk through the code, or do you want to try to go through it yourself and ask me questions?
It says repository not found.
Oh, sorry, not found. Yeah, if you try to clone the repo locally, the link, like the direct copy paste link is not correct. You'll have to click on the top right corner to get to the repo and then use that link.
Where's the,
Okay, great. I hope everyone has done that. So you open this lab 1, open in Colab, view on GitHub, whatever you choose. Yeah, okay. So, yeah, lab 1 is just gonna go through conversion. All the labs together will end up building like this multimodal RAG system, but the first one is going to focus specifically on conversion. There's a few imports and installs that you have to do. Shouldn't take too much time there. More imports here. I put this here. If you have a Mac, you may need this because it'll sometimes hang because a lot of the models are not optimized for MPS, and then it's a problem, but this just forces CPU. Okay, so for the first piece of this, which is arguably the most important piece to remember, how to do simple conversion, right, or how to do conversion. So this is the document that we're using. We're actually going to use that Docling technical paper for conversion. If you go through it, you'll see it's a reasonably complex scientific article, right? You've got headers, you've got weird side text, images, captions, lists. There's some tables in there somewhere. So reasonably complex document. Take your Docling paper. So here you create a converter instance, document converter, right? You set the Docling paper, so you convert that Docling paper, and your result here, so this doc result is going to be that Docling document as talked about before, right? So once you do that, you have a converted document in Docling document format. For time reference here, this took 4.5 seconds for a, how many pages is that? 8-page document. To be fair, it's not a scan document, so I don't believe it needed OCR, but 4.5 seconds for an 8-page document is reasonably fast. From there, so you take that Docling document format, and we'll explore that format later, but from there you can export it into various formats. Here we're going to go ahead and export to Markdown, and as we can see, when we print out the first 2,000 characters, we can see it's relatively what we would expect, right? Later we'll look at the full thing, but for now we're just seeing that that Docling document now is something that we can work with and manipulate. So from that document, sorry, is everyone able to do the conversion? Was everyone able to run that initial first line? Okay. Any issues? Okay, no issues. All right. From there, we can actually go ahead and explore what Docling is seeing essentially, right? So we can see that there's 8 pages in the document. There's 1 table and 6 pictures. And then we can export it into various formats. So from the Docling document, we can export to Markdown, HTML, we can export to dict or doc tags. If we save the document as Markdown, right, if you run that, save as Markdown, you'll just create this Markdown folder, and we can go through it, and you can kind of dig through this yourself if you want to, but if you go through it, you'll see it's preserved a lot of the structure of the document in this conversion to Markdown, right? You can see these headers are going to be preserved. The text is, I haven't read the whole thing to be fair, but I'm pretty sure all the text is in the right order. These links are preserved. You see these lists are going to be preserved too. That's fun. Images, so here we have a placeholder for the images. We'll show you how to work with those in a second. List, let's see if there's a table here, a table in Markdown format. So again, just to show, right, we've done basic conversion from PDF to Markdown, and it's preserved a lot of the structure. So useful already in terms of the conversion to Markdown. In this, we also are going to convert it and save it as a JSON. The reason why we do that is because JSON is what the Docling document format is in. And so you can kind of explore what the Docling document format looks like yourself. I can't read JSON myself, but if you go through it, you can kind of see It's a very metadata-rich representation of the document, right? So every single piece of text, every single chunk of text is going to be saved with a ton of metadata, including what type of text it is, the location on the document, coordinates, right? Let's see if we scroll through. There'll be body text. If you keep going, there'll be like header text, title text, there'll be tables, right? All that stuff. So all of this metadata is stored within that Docling document format, and the serializers that are built into Docling are what allows you to export from that Docling document format to all those various more AI-ready formats that you would want to use. Okay. Is everyone following along so far? Was everyone able to do conversion and export? I hope. No outstanding question.
Running very slowly.
So, great point. The first time you run through it will run slowly because Docling only downloads the models as it's needed. So when the first time you run conversion, it has to go and download all the models that it needs for conversion. The second time you actually run the convert on a different document, it'll run much more quickly because all the models will be cached. Anything else? Okay. Great. Okay, so from there you can also work with different parts of the document, right? So if you remember from that JSON, that document format, the different types of text within the document are going to be tagged differently. Because of that, you can work with the tables specifically if you wanted to. So here we're taking this document. If we open it up, we can see it's a much more table-heavy document, right? We've got, let's see. Saying that. Oh, yeah, bunch of tables in this document, right? More complex tables here, little table there. Okay, so we're taking a more table-heavy document and we're doing the same thing. We're converting the document, but this time we're going to convert it. We're going to export those tables specifically to different formats, right? So here we're going to export them to data frames. You can also export them as CSVs, HTMLs, etc., right? So this is going to be useful if you have a document that is very table heavy and you want to save those tables into formats that you can more easily manipulate or search through. And again, you do the same thing, right? You're creating your document converter and you are converting to, you're converting your document with these tables exported in these various formats. And here, if you scroll through them, you can see all these tables are going to be displayed in the format, I think it's HTML. Yes, I think this is HTML. So these are all HTML stored tables here. Again, this is just printing out all of the tables that it's discovered in the document. Okay, so earlier I also mentioned there was the image and figure extraction, right? So in that document there was the placeholders that existed for the images. You can also work with those images separately. There's a few things you can do, right? So because Docling is recognizing those images, and I forgot to mention this, but within the Docling document, images are actually going to be stored in base64 format, right? Which then allows you to export those images separately or save those images as you see fit. But here we're going to modify our PDF pipeline, right? So now we're specifically targeting the PDF conversion pipeline. We're going to set the image resolution based on, right, how fine-grained you want your images to be. We're generating page images and generating picture images. What that does is going to store every single page as an image, and it's also going to store every single image as an image as well. So later when we go to retrieve those images, we can display the images, both of the pages, but also of each individual image. Again, we're creating our document converter instance here, this time with the PDF pipeline options, and then we are going to convert our document, so we're converting that Docling paper with our modified PDF pipeline, right? It's going to preserve the images. Once we convert that, we have these 8-page images saved here. We can also extract the figures and tables as images. So if you want to use table and figure processing that is separate from what Docling provides, you can just store those tables and figures as images and then reprocess them separately, right? If you maybe had a more advanced model that was more tuned to your specific tables and data. So here it's extract one table and 6 figures as images. Now we can actually go through and just look. This is going to just print out what image content has been pulled out of the document, right? So we can see here, because we stored each image as an image, we can also display each image as an image. We can see the image, we can see the caption that goes with the image. That's pretty important, right? So for every single document, or for every single image within this document, there actually was a caption. If you go to the document itself, you can see that. Let's see, yeah, so all of these images have like these captions below them. Again, because of the structural recognition that Docling has and the reading order information that it has, it's able to recognize the image as well as the caption that goes with the image, and then it also does some basic OCR to extract the text elements out of the image. Yes.
How granular can you get with the resolution? You had like a line at the top that was like 2.0 or something.
Yeah. So here we set it to 2x resolution.
Yeah.
Theoretically, as granular as you wanted, but it would just increase the processing time. I'm not quite sure how much you could store in base64 format, but I think it would be beyond what you would possibly need it for.
Yeah. Thank you.
So what if you have an image like in one page that's like super big and I have a caption on the second page? Like, does it match up the image with?
It should. So if within the document you'll see that there are some images that span, or at least there's image on one side and caption on the other, because the page order, like, it also recognizes text that spans pages, so the image plus the caption shouldn't be an issue in terms of the spanning of pages, because it recognizes that the document itself is cohesive within those pages. Yeah, it's not like individual, yeah.
So actually in the images, I can see that it's doing OCR. So there are a couple of bar charts here and also I think pie charts. So it's kind of giving the text, but it does not do any form of shape recognition or anything like that, right?
No, yeah, so it's
But
using, yeah, go ahead.
Oh, no, that's,
Oh yeah, so it's using some very basic OCR models just to extract text out of the image. Actually, you bring up an interesting point, because as we move forward, we will also talk about how to process those images separately using like a specific image processing model. But in order to save weight and processing time, it doesn't use a heavy OCR model to process those unless you choose to. But yeah, so once we inspect, so we can see, right, we see all these images that it's extracted, we see the captions that go with each image, so we have all these images, blah, blah, blah. Okay, this next part, we can just kind of see what Docling is seeing during the conversion, right? So this is just important to recognize where Docling is seeing each piece of text. And these bounding boxes are going to be drawn based on the information that's in the Docling document. So it uses this function called layout visualizer within Docling. As you can see, right, it's recognizing section headers, text, section headers. It even recognizes this sideways text as a page header. We have list items here. We have footnotes here, picture, caption, section header, text, list, etc. Right? So this is just to show, right, within that Docling document, you're preserving a ton of the metadata that's allowing Docling to essentially see the contents of your document. From there, so there are a couple enrichment features. So as you brought up, right, there, you want to be able to process those tables potentially, right, with more advanced models. This is going to be the part where your Colab may or may not crap out, because it's going to need to download a vision model, which is going to be a 2 billion parameter model, and Colab sometimes will not give you enough space to do that. But here, what we're doing is essentially we're taking Docling has several visual language models integrated directly into it that you can just choose from. You can also theoretically select your own vision model. All that Docling does is takes the image, right? Because Docling's recognizing and separating each individual image, it takes the image, passes that image with your chosen prompt to the model, and then when it gets the response, it essentially links the response to the image, right? So here we're choosing the IBM Granite Vision 3.22b model. Our prompt is a very generic prompt. It's just give a detailed description of what is depicted in the image. Again, we're doing this with the picture description VLM options, right? So we're using the VLMs that are already included within Docling. You can theoretically choose a different VLM if you wanted to. Actually, when I ran it locally, I used Olama for that because it just runs faster than trying to download and run everything locally. So, but we're using the same model, and it's the same concept. It's just taking every image, passing it with a prompt to Olama with whatever model you chose. Same prompt there. And once it does that, you can see now, so for every single image, not only does it store the caption, right, which is just extracting from the document, but now you also have an annotation that goes with the image. So this annotation is going to be generated from the image plus the prompt that you gave. If you had a lot of documents that were very specific in the image content, like you knew that your document was going to have a lot of pie charts, right? You could fine-tune your prompt to focus on extracting information out of the pie charts if you chose to. Here we're just doing something general because we know that there's a bunch of random images in here. So here we can see this annotation. This image depicts two different document processing workflows side by side, blah, blah, blah. So it's rather verbose. You could probably cut that down if you wanted to. But as you can see now, for every image, there's a caption and annotation that goes with it. This is the part that's going to take probably your devices a long time, so we don't have to stay on it for too long. But oh no, I'm happy to answer questions while people.
So here we're essentially asking an LLM to describe the image, right? So what exactly is Docling's part here?
So Docling technically doesn't really play much of a role here, except for being able to extract the image right from the document. So if you had a scanned document, it actually can bounding box where the image is, and then also pass that image to whatever VLM you're using, right? So it's storing the images separately, but also taking the response and storing it with the image.
Okay.
So like linking the response with the image while also passing the image correctly, right? So like instead of passing the whole document to a VLM, you can actually segment the document to the various images that are within the document.
That's pretty useful.
Did you run to get that? Which one?
It would be this cell right here. Here I have it set up with Olama. In the pre-work, there's instructions on how to set up Olama to run it, but I have this Granite Vision model downloaded locally already, and so
Can you just scroll a little bit?
yeah,
Maybe
this is
ours it's cell 19, but mine's not displaying anything.
which one is cell 9?
If run local VLM, yeah,
Oh yeah, okay. So
but it doesn't display anything.
we had to change. If you want to go and set in Colab, if you want to try to run it in Colab, you just want to set run local VLM equal true. The logic there didn't work out when I initially wrote it, but just set run local VLM equals true and you can run it. If you are trying to run it in Colab though, again, it will take some time because not only does it have to download the model, but it also has to inference against the 2 billion parameter model a lot of times, so take some time. Go ahead.
I'm assuming for PDF you have a native PDF parsing.
This
Like,
so that
when it's a real PDF with
VLM,
text and structured data, you
instead
try
of-
to extract that
it's
first,
saying if
right?
it's in
Yes,
Colab,
yeah,
it sets
exactly.
it to
And is it
false.
Docling's
But
own technique,
after
or do
this,
you leverage from
Okay, so
multiple?
go
Just
above.
change
For
this
the native
to
PDF parser
local
is
VLM
Docling's own
to
technique.
true. Or change that one to true.
But
and use the
so
other
like as you were
model.
saying, right, it defaults to trying to do just extraction.
Yeah.
But to force it to do just extraction, you can also set do OCR equals off. And that would save a lot of processing time if you know for a fact that all your PDFs are gonna be don't require OCR.
For this exercise, did we want to use either the VLM or the Olama?
Yes, yeah.
And
It's one or
you were
the
saying
other.
that Olama is more likely to run on Colab or.
Olama is more likely to run if you're running it locally. It just is an
Okay.
easier way to. Anything else? Everyone generally get the gist of what I'm saying? Okay, that's all that matters. You guys can go back, this is all gonna stay up, so if you wanna keep trying it out, or if anything's taking too long to run right now, you can always go home and continue to give it a shot. Okay, from there, hopefully, unless your computer's really fast, you probably didn't get through this specific part. You can cancel that for now if you want to keep going. Actually, never mind, the rest of it isn't gonna be like that much faster, so you can just sit there and wait for now. But from there, right, so now we know how to work with tables, we know how to work with the images, right? We can do image descriptions with the individual images within your documents. The next piece is going to be that visual language model piece that I talked about before, right? So that third pipeline within Docling that takes every single page, right, individual pages of the document and passes it to a VLM that's fine-tuned to do the conversion from scanned document to Docling document format. There's actually 2 models out. The older one is small Docling. The newest one is Granite Docling. Here we're just going to use small Docling because it is a little bit easier to get the MLX optimized version of it. That being said, Granite Docling and small Docling, both open source, both Apache 2 licensed. You can get them both off of Hugging Face if you wanted to. again, we're downloading it and then we're doing the document converter, but this time using the VLM pipeline, right? We set the VLM pipeline options here, and then we are doing the VLM pipeline conversion, and we do the conversion and we print it out and save it. We can also see, if we look at the markdown, we'll see it's going to be basically the exact same thing. And that's kind of the goal, right? We want the output of the VLM pipeline options to be as similar as possible to the standard pipeline options. If you look at the JSON, it'll also look very similar. But yeah, so actually the VLM models are actually trained on a lot of data that Docling converted, right? It's taking existing PDFs, converting them using the standard Docling pipeline, and then using that data as training data for the VLM. But again, the idea here is you can take documents of any format as long as you can scan that document or take a picture of that document, and you can upload it to the VLM and it does the direct conversion for you. But yeah, that is the last piece of the first lab. Yes, that is the last piece of the first lab. If we go back to the slides, oh, go ahead.
In your experience, are there some things that you would want to use the VLM for, where certain kinds of documents it works better for, and others where you use the native Docling?
Yeah, good question. So on a production level, we have yet to recommend using the VLM for, because at really high volume, it just becomes too expensive. That being said, if you have not that many documents and you know that there's going to be a lot of random scan documents within that, the VLM may just be more convenient to use, because then you don't have to like modify the PDF pipeline to account for like scanned documents and unscanned documents.
But it's not like it's not like there's very specific types of documents with, like, I don't know, a lot of pictures of people or something where the VLMs just generally work better, so pull those aside and use the VLMs on them versus everything else, use your generic. Is it?
Right,
not
yeah,
like
not
the-
necessarily. I think that generally, especially for bulk operations, you're going to want to use the VLM. And actually, though, sorry, you're going to want to use a standard pipeline. Actually, the one thing that is cool, if you go to the actual Hugging Face page for the VLM, so this is the Granite Docling 258 million parameter model, there are a couple of queries. You can upload your own document as well, or upload your own image of a document, but this is just to highlight what the VLM can do and also some features the Docling can do that I just didn't mention, right? One of the things is going to be formula representation. So Docling can actually take formulas within the document, convert them into LaTeX format, and allow you to export in LaTeX format, which is pretty important for scientific documents. But again, right, there's a lot of different queries that you can ask the VLM that you couldn't necessarily do with just a standard Docling pipeline, and that would largely be the main benefit. But at scale for document conversion specifically, it's just not necessarily the best method. Go ahead.
So is it possible to maybe plug OpenAI models or Gemini models for converting the images to text?
Yeah, anything you want. I mean, here we use an OLAMA endpoint to do that. Where is it? Where'd it go? Right, yeah, here we're using the OLAMA chat completion URL to do that. But yeah, theoretically you can use any endpoint that you want to do that. It's just as long as it can take an OpenAI API compatible input, it'll work. Yeah.
So this example with a nicely formatted PDF of a scientific written in LaTeX and everything. Do you have a demo with messy handwritten notes or 100 pages concatenated faxes with low resolution and rotated missing text?
Yeah, so for handwritten stuff, I wouldn't. That is one case where I wouldn't necessarily recommend using the standard pipeline, because the OCR models that exist within the standard pipeline aren't necessarily built specifically for handwriting. Now, I will say the Granite Docling model has been trained on messier text in the sense that they actually took a lot of images of documents and artificially, what's the word? Like mess them up, like put them in weird situations, angle them differently, put like random objects around them to train the model to be able to recognize text in different environments. That being said, for handwriting, it's very difficult to say because some people have good handwriting and some people have bad handwriting, right? So it would really depend on the specific quality of handwriting that you're referring to. But I mean, the demo space is there. You can just upload. If you have a specific document that you're like, oh, I wonder if it'll work on that, you could try uploading it and see. Worst case scenario, what it would do is identify the handwritten text as an image, and then from there, because it's able to bounding box that image of the handwritten text, you could process it using handwriting recognition models that would be maybe more effective specifically at handwriting. But that would just allow you to process the document that can be processed using Docling into text using Docling, and then process the more complex handwritten pieces or the messier handwritten pieces independently, right? So that way you don't have to run your full handwriting recognition model on the entire page of every single document that you do.
So I have to develop custom extensions based on this logic.
Yeah, it just depends on how complex the handwriting is. Yeah.
Is it designed to handle any kind of like markup on it? Like if there's like highlighted sections or someone circled something, does it recognize that? Or if someone wrote, on the side of it, like very important, does it recognize that as separate from the text, or would it just embed that in the text and
It
try to?
would. I honestly am not 100% sure. You would just have to test it out to see. Yeah. I don't know how much like complexity was added to the training data beyond like some artificial manipulations, but yes, I'm not 100% sure about that kind of complexity. Anything else? Okay, great. Yeah, feel free to check out this Granite Docling demo. Actually, the Granite Docling model was the #1 trending model on Hugging Face for a couple weeks, and the CEO of Hugging Face actually tweeted about it. So very cool. Feel free to give it a like. Very cool. Okay, great. So why is it that we use the Granite Docling model, or why do we fine-tune a model specifically to do the document conversion? Well, there's also other VLMs that people like to use for document conversion, right? There's a Qwen 3B model, there's a Pixel 12B, 5, 4, 14B. All of these were given the same prompt, is to convert the document into Markdown format. As you can see, all of them failed in some ways, right? There's some mistakes in what they do. Sometimes the table isn't preserved correctly, sometimes text is missing. But none of these models are fine-tuned specifically to do document conversion. People just kind of rely on them because they're the existing top-of-the-line vision models. Obviously, beyond the fact that they're not fine-tuned to do document conversion, they're also going to be way heavier. So in terms of processing time, all of these processing times are on a Mac, right? So a single page processing time is going to be pretty exorbitantly expensive if you're doing a lot of documents. Granite Docling, same document, same prompt, also same device, right? 4-second processing time for the same document, and you also, right, better accuracy. Okay, so the next two labs are gonna, how much time do I have? The next two labs are gonna focus on, sorry, at 1:30, right? Okay, never mind, we have some time. Okay, next two labs are gonna focus on RAG, or Retrieval Augmented Generation, or at least the pieces that Docling can actually assist in RAG. Is everyone here familiar with RAG already? Does anyone need a refresher? Okay, it seems like everyone generally has an idea of what RAG is. Okay, so the key piece that Docling is able to assist on is how you take your documents and actually upload them or input them into your vector DB, right? So going from document to vector DB, and then within that RAG process, right, you want to be able to retrieve relevant information out of your vector DB when you have a query, so that when you actually generate a response, your LLM has the right relevant context out of your database. So how can we get relevant chunks into our vector DB, and how can Docling actually enable that? Chunking is something that is actually very important in terms of creating vector databases. So this is an example that dumb example, but if you think about an embeddings model, all embeddings model have some sort of context window, right? You can't just embed an entire textbook in one go into your vector DB. You have to break it up into small pieces so that your embeddings model can actually vectorize those pieces. So if your embeddings model, for example, has a 512 token context window, and you have a piece of text, you could say, okay, for this text, let me just break it down into 512 tokens, 512 tokens, 512 tokens, et cetera, et cetera, et cetera, right? That would be the naive way to do it, and technically it would work. But what ends up happening is you may have an example like this, right? So your first chunk might end with the company's revenue increase by 25% Q3, and then that's 512 tokens. Your next chunk starts 2024 compared to Q3 2023. So if you were to ask what the 2024 revenue growth was, you might not actually get chunk 1 at all because chunk 1 doesn't mention 2024, even though the actual information that you need is in chunk 1, right? So when you do the retrieval, you wouldn't get chunk 1. So you need chunks that are actually semantically aware and structurally aware, right? You need chunks that are broken down based on human reading order and content, right? So if you have a semantically aware chunk that in this example just breaks down by sentence size, you can see that the 2 chunks are going to be more semantically coherent, right? And so when you retrieve the chunks, you actually have all the relevant context you need to answer your question within each chunk, right? So you need complete self-contained thoughts within each chunk, clear topical boundaries within the chunks, sufficient context in each chunk for retrieval, and of course those natural section breaks are going to be preserved. So how does Docling actually enable that? The second lab actually runs very quickly in Colab, and we should be able to get through this very quickly. So chunking. So what are some ways that Docling can actually enable chunking? Again, it's based all on Dockling's structural recognition. Here you have some more imports, installs, imports, etc. We're going to do the conversion again. So here we're doing the PDF pipeline options conversion. We're going to turn off OCR just to increase or decrease the processing time. And the document we're going to use is going to be an arguably more complex document, right? So we use this Midwest Food Bank annual report, super weird formatted document, right? Not very commonly shaped document at all. We like to use this because it's just such a weirdly formatted document that it kind of shows off the chunking capabilities Docling has. It's funny because we've been using that specific document for like a year now for all the workshops that we do. So the Midwest Food Bank is getting like a weird number of hits on this one page, and we have no idea why. But
You told them?
no, we've mentioned nothing. No one said anything, so it is what it is for now. Okay, so we're using this document. We run our converter, right? We created this PDF pipeline
Say
options for
anything too.
converter. Right, that's true. One day it'll just be taken down, and we'll have to guess why. But we convert the document using the PDF conversion options that we set here. And again, we have this doc, which is going to be that Docling document. And now we can create a chunk visualizer, right? So this is just going to give us, well, it does what it is named, right? It's going to visualize the size and shape of the chunks for us so that we can kind of see exactly how the chunking is improving or not improving. So the chunking interface that Docling has is very simple. It's just this base chunker interface. There's a chunk and there's a serialize. Chunk is going to, well, chunk the document, and the serialize is going to actually order the text within the chunk. So there's a couple of advanced chunking methods that Docling is going to enable based on the structural recognition, right? The first one is going to be the hierarchical chunker. So that's chunking strictly based on document hierarchy. And what that means is like paragraphs, sentences, that kind of thing, right? So here, when we actually use the hierarchical chunker, so we're creating our hierarchical chunker here, and then we're going to chunk our document using the hierarchical chunker, we can see not great, right? So it's chunking strictly based on structure, but you end up with a ton of really small chunks, right? Probably because this document is so weirdly formatted and there's all these like little small lines. And then you have one really big chunk, which is bigger than 512 tokens, which is the context window length of our embeddings model. So not awesome. We probably want to do something about that. Next is a hybrid chunker, which is what we actually recommend in terms of chunking with Docling. So the hybrid chunker is not only going to chunk strictly based on hierarchy, but it's also going to incorporate size into that as well. The hybrid chunker can actually automatically detect the context window of your model. And so now when we chunk it this time, there's 73 chunks as opposed to 160 chunks. And we can see it doesn't look like it's better, but it is actually a lot better. So this time we only have a little over 35 very small chunks. We have a slightly better distribution of chunks all the way across. And now our maximum chunk size is 506, right? So now we actually have chunks that are within the window that we want. And there is not nearly as many tiny chunks. Okay. I hope everyone's able to run that. It should run very quickly. A couple of things you can do with that chunker, right? You can manually set the max tokens if you wanted to. Here we set it to 128 just to mess around. You may want to set it to smaller if you wanted more fine-grained retrieval, right? If you had maybe a document that was just like a list of things, you may want to be able to chunk just based on every item in the list. Regardless, you can set the max tokens to whatever you want. Here we set it to 128 and we run the hybrid chunker with 128 max tokens. You can see better distribution, but also we have a max chunk size of 128. Great, okay, so that's just fun little example. This is my favorite part that Docling enables is contextualization within chunking, right? So if you think about chunks, if we go back to this document, so this page in particular, if we think about the chunks in this page, strictly based on hierarchy and even in a hybrid chunking scenario, it probably would take this first part as a chunk, right? The second paragraph might be its own chunk. Maybe this list thing would be a chunk, right? But if you think about what happens when you chunk like that, if you were to ask the question, what was the message from co-founder, president, CEO David Kaiser, you may only actually retrieve this first chunk here, right? Because that's the only chunk that actually mentions a message from co-founder, president, CEO David Kaiser. And if we go back and we actually look at the original chunks, we can see that that's probably what would happen, right? So in the first, let's see, in this first chunk, right, we have no one could have predicted the events of 2020, the global pandemic, blah, blah, blah. So that's the original text of the first chunk, and that's just that first paragraph there. When we actually run the contextualized chunker, what Docling is able to do is able to recognize, because it recognizes that this is the header and that this is the body text that goes with the header, for every single chunk of that body text, so this first chunk was no one could have predicted events, the second chunk was all MFE locations, so that's just the second paragraph there. Instead of having those chunks as independent chunks, neither of which mention a message from co-founder, president, CEO David Kaiser, Docling is able to append every single chunk within that section with that header text, right? So now, if you were to search up a message from CEO, President David Kaiser, you would get every single chunk that's under that header. That's my favorite part about what Docling can do for chunking, right? It's taking that structural recognition and actually applying it in an advanced way to the chunks that it's creating. Okay, that is all for chunking, yeah.
Sorry, I have a question for that because, so the example you gave, like it's taking the header, right?
Mhm.
But if you think about, for example, a Markdown documentation, sometimes you would have some intro in the H1, and then you have H2 headers, below, and like, would this H1 sort of introduction be repeated in the H2 headers? Like, how do you, in the H2 sections, can you, this contextualization is actually probably super important. Is there a way to tune it within Docling, or is it, whatever the heuristics are here?
Yeah,
It's based on a lot of like.
Right.
assumptions,
So it's a bit difficult because headers and subheaders aren't necessarily distinguished in Docling. You can kind of see that in this markdown representation, right? Like you can see that these subheaders all are at the same weight as the primary title and header are. So that's not necessarily something that Docling is discerning. What you may consider doing, so what Docling does when it's doing the conversion, it's doing serialization. You could technically implement your own custom serializers that would maybe have more advanced header recognition. But if you look at like the actual JSON, it does not distinguish between the primary header and the secondary header. So no, sadly, that is a feature that would not exist within Docling. Unless maybe you could figure out how to implement it custom. But
Yeah, no, I mean, yeah, if you don't have any hierarchy in your headers after the PDF extraction, it's kind of it's finished already.
Yeah.
And if you come from Markdown, you keep the because the Markdown initially had it, right? If you come from a Markdown
Yes,
document
if you
or
come
some
from a
HTML,
Markdown and you're converting it, that's a good
or
question.
is it
I've
just
actually
a
never
Docling
thought of that.
limitation, but you only have one type of, you have headers and content, headers, content.
It may be a Docling limitation, but you should try. I'd actually never thought about whether or not the header hierarchy would be preserved from Markdown to Docling document back to Markdown. I'm not 100% sure. I'm not sure that Docling actually has the necessary text representation to represent header hierarchy within that HTML form or that JSON format, but that would be an interesting test.
You can get font size and bold from the original text.
Yeah.
So that might be a distinction.
It is, I mean, in the document, you definitely have it, but then if Docling doesn't.
Right, Docling's not preserving the font size or font type.
Can't get it? There's no
Once you do the conversion, the font disappears.
Does it identify the font?
Not post-conversion, yeah, it doesn't store it.
But does it, can it read it? Like, is that something it can recognize?
Like different fonts?
Yeah, like, is that a metadata thing that's in
Like,
there?
it would recognize the different fonts insofar as it could see that one font is weighted heavier than another and recognize it as header, but I don't know that it would necessarily say, like, this is italics and this is Times New
Just
Roman.
didn't know if that was a piece of metadata that.
Oh, right,
that was
right,
in
no,
there.
no, yeah, it
Yeah.
wouldn't be stored, yeah.
Does this also work with other languages?
Yeah, so there is multilingual support. It depends on what OCR model you're using as well. But the granted Docling model also multilingual, including Arabic, so like including languages that are read left to right. You would have to try it out and see what languages are supported, but there is a variety of Asian languages, Roman languages, or like English languages, and other assorted languages. I'm just not sure what the limitations specifically are. Yep.
I don't know if this was in the other example, but if you have formulas, I guess during the conversion process, are the actual symbols preserved, or are they like in a different format?
Yeah, so for formulas, you actually need to enable that specific feature within the pipeline, but once it's enabled, it's stored in the LaTeX format. Yeah.
We did not discuss how the system is implemented, right? What's the secret sauce of the Docling itself? It's completely open source, so we can look at everything, right? But is it standard GNI application, or it's like there is some agentic workflow and there's some agent underneath? And maybe you can tell us a landscape of other solutions, right? Some people developing agents for document parsings, and this, some people just use straightforward GNI function calling, and that's it.
Yeah, I think the main benefit of Docling is actually combining the various methods of conversion into a single pipeline, right? Like some people might just use OCR for their document conversion, or some people might have to run table form models on their document conversion separately to their OCR conversion. Docling just kind of puts it into one nice single pipeline with toggles that allows you to just input the document, turn what toggles you need on, and the output is a document that you can then export into the various formats. The primary, I guess the secret sauce would be there are some models within Docling that are trained specifically by the Docling team, so their performance may or may not be better than what already exists in open source. But that Docling document format and that Docling document representation that's very hierarchy or metadata rich and that represents hierarchy very well, that is what helps the exports into more hierarchical representative formats. So I guess, I don't know if that answers your question, but it's more like it's preserving the hierarchy of the text through the correct combination of models being used on the document.
So basically, it's not an agentic solution.
No, no.
And do you know, are like competition, like landscape? Some people develop agentic solutions, and why would they do that if you can basically solve this problem with basic Gen AI?
My understanding is that a lot of the agentic solutions do just rely on Gen AI. They're just tool calling to Gen AI solutions like Docling. So for example, we have integrations with LM Studio, right? And within LM Studio, you can actually create a Docling tool or a Docling agent that'll do the document, or a document conversion agent that calls upon Docling to do the document conversion. I couldn't tell you specifically why people rely on agents as heavily as they do now, because I guess the main thing would be like if you had a corpus of data that had varying degrees of complexity of document and you wanted an AI model to be able to determine what document was being converted and what the best pipeline would be, maybe you would have like access to several different tools for several different types of document. But a lot of that can be just done procedurally without the use of AI, right? Like you can just say if you detect the format to be, PDF, then use the PDF conversion pipeline. So I think it's just added complexity that's not necessary.
So the objective of all of this is to create documents that you can convert to rags, and then you can point LLMs at them and do and read all that data and do interesting things with them, right? So I don't have a ton of experience doing that second piece of it. Are they does adding this metadata around like different chunks being connected to each other through metadata and things like that, does that add a lot of complexity to the RAG index that makes it harder for an LLM to parse it? Like or is that sort of standard? Do you know what I'm saying? Is that adding like a whole additional dimension to the RAG that blows up potentially blows up the LLM?
Yeah, good question. So the primary goal is to convert it into a format that is more understandable for RAG, right? So like we like to use markdown representation when we're inputting into a vector DB and then using RAG on. But if you don't use something advanced, right, like we were mentioning before, you lose that hierarchy and those relationships, and then your retrieval is inaccurate. So it's not so much that the LLM would have trouble understanding the complexity. The complexity is added because it improves the retrieval step, right? So like when you're actually doing the retrieval, like having those relationships within the retrieval process increases the quality of the retrieved chunks. The LLM is still just going to get fed a block of text, but this time it has more hierarchy to it. That makes sense. Like the metadata largely isn't going to be fed directly to the LLM because we're exporting it into another format that's, for example, Markdown, that isn't going to save a ton of the metadata that was in the original JSON representation.
I see. It's just gonna inject it into the data that is in the RAG.
Right.
model.
Yeah. And actually, so that third lab, if we're okay to keep going, I hope we are. We're running a little bit. Well, actually, no, we're fine. But the third lab is actually going to be building that full RAG pipeline and just seeing how Docling is going to be able to improve a RAG pipeline with its capabilities, right? So this third lab is going to require you to have a replicate account unless you run it locally, which in case it may take a while to run. But part of the reason why it requires a replicate account is that for the inference part, for the generation part of our RAG, we are going to be using Granite 3.38b. It's an 8 billion parameter model, so for some devices that's going to be pretty heavy and it's going to take a lot of inference time. Replicate is a cloud hosting service that allows you to host, or we actually host the models on Replicate, and then you can go and get some credit for Replicate, and you get your Replicate API token, and you can put it into your secrets, and it'll run based on your Replicate account balance. But your Replicate account balance can just be padded with the credits that are available through the pre-work. But without further ado, so this is the first parts are going to be very recognizable to you. Installs, imports, imports. So here we're going to do a lot of LangChain stuff for RAG. So we're building this RAG out of LangChain. Here we're selecting our embeddings model. It's going to be the Granite embeddings 30 million parameter model. Here we're loading the Granite Vision model. We're using the Replicate API token for that. So we're using the Granite Vision model and the Granite 3.38b instruct model on Replicate. Again, you have to set your Replicate API token to whatever it is that you end up getting from Replicate. From there, we are going to actually do the conversion again. So this time we're taking that PDF document, right? We're taking the same one just because we like the complexity of it. We're taking that document and we're doing the PDF pipeline conversion again. So we're converting this document into Docling document format with generate page images and generate picture images equals true. We're going to do that for a feature called visual grounding, which we will explore in a second. We're also going to create a doc store for visual grounding. So this is going to take all of those images, saved images, and store them somewhere so that later when we retrieve them, we can actually display what the retrieved images are. Sorry.
So there are two files in the Git repo. There's lmstudio.rag.ipynb and there's rag.ipynb.
Here's RAG.
Rag, okay, they look kind of similar.
Yeah, the LM Studio one you need to download LM Studio and download and run LM Studio 4. It's, again, just another way to inference on local device instead of relying on a hosted server.
Oh, okay, sorry, I
Yep.
missed that.
Any other issues, questions? And then we just do our document conversion, right? It's the same as before, except this time we are creating our document conversion with the visual grounding support. We'll see what that means in a second, but once the document is converted, you can see there's 20 pages, 2 tables, and 54 images within the document. So we can see it's a reasonably complex document that we've just converted. So there's a few things that you need to do to enable this visual grounding, right? So first, it's going to be taking the text and actually adding the locational metadata to each chunk. So essentially what we're doing here is for every single piece of text, of chunk text, we're also going to add this DL metadata field to the metadata within that chunk so that later we can actually use that locational metadata. So this is going to be the coordinates of where it is on the document. We can use that locational metadata to draw bounding boxes for visual grounding. We do the same thing for tables and then for images as well. The main reason why we have to do the images and the tables separately is because the images specifically require special processing. And the reason why the images require special processing is because we are going to use that Granite Vision model to take those images and create the text representations that we did before, right? So in that first lab, we took images, we sent them to our visual language model, we got text descriptions out of those images. Here, we're going to get those text descriptions and then also embed those text descriptions as well, so that way when you actually do the RAG on your vector DB, you're able to also search, essentially effectively search across your images, right? Because you can't just embed your images into your vector DB. We're creating a text description of those images, embedding those so that later when we retrieve the text description, we can also retrieve the relevant images as well. So that's what we're doing here, right? We're taking those images, we're giving it the same prompt as before, right? Give a detailed description of what is depicted in the image, and then we are embedding those images, processing those images and adding that locational metadata to all the text chunks as well. So now we've processed 54 images, yep.
I'm sorry, just conceptually, so when you're dealing with images, and you're vectorizing them, are you vectorizing like the description only, or are you vectorizing
Yes.
the actual image itself?
Yeah, you're vectorizing the description only, but you're using the locational metadata of the image to store the description, if that makes sense. So like for the tables and text, we're storing the location metadata of the actual tables and text.
But in terms of the retrieval, it's really retrieving based on the description that you've created of that.
Exactly, yeah, exactly. Storing the locational metadata just helps us later when we do the visual grounding piece.
So you have to have a good model that's able to look at a photo essentially
And understand
give a
what's
very good description of it.
Yeah, exactly. And that's gonna largely be the case for any of the image processing that we do, and as in the first lab too, like we're using a very generic prompt here, but for example, if you had like maybe your documents had a lot of medical based images, right? You could have a document, you could have your prompt be like, this is a medical image, like describe to me what this image is depicting. Like fine tuning the prompt for the type of image that you have is going to give you vastly better results in the image description. Here we're just using the generic prompt because we're assuming we have no clue what's in these images.
So going back to that document, your favorite one.
Yeah.
At the front page, they had the photo of the director of it,
Yeah.
right? So in this case, if you fed that in, it would just be like, oh, here's a picture of a guy. Does it know that this guy is David Keyser, or does it not know that really? Because I'm thinking later, if you want to connect that back, somehow it has to be captured that this is not just some generic guy, but it's actually this David Keyser guy who's the CEO of this organization.
That is an interesting question. So the images are going to be stored with their caption, but I'm not sure if that piece is recognized as the caption.
Because there's no caption here.
Right.
But isn't the bounding
But
box?
it's annotated, right?
I thought you were capturing the bounding box location.
So yes, you will, when you retrieve it, you will see the image itself, but it wouldn't necessarily recognize it as David Keyser, right? Like,
Would it be under the header though, a message from co-founder, president, and CEO David Keyser?
it would really depend on the reading order, and I'm not 100% sure that it would be. I don't think it would be because the images are stored separately from the text, right? So like the text isn't recognized.
What was that annotation though?
So the annotation is generated just from the image and the prompt that you're sending with the image to your model. It's not taking into account any of the text that goes with it. And so it may, in fact, not recognize that.
So let's say I've given a vision model and it says a person on the left hand, I have a B box, right, bounding box in my JSON. And on the right, I have the message saying message from the co-founder, president, and CEO. So when it does hierarchical chunking, does it take all of it together because they're part of a similar structure, or again, does
Would
not
it take
have?
the image as well? Is that what you're saying?
Yeah, does it take the image description?
No. So the
Below
chunking is
the,
only text. The chunking is only based on the text hierarchy. It doesn't incorporate the image hierarchy into it. That said, you could potentially, what you could do is, because the images within the stored JSON are going to be stored in a serialized way with the text, you could just increase the scope of your retrieval and say, if I'm retrieving this chunk, then I want to retrieve the chunks around it as well. And maybe that would help you capture like the image description with the image. But I just am not sure that if you're strictly retrieving for.
So if somebody put a prompt in, hey, give me the picture of David Keyser, it's not gonna be able to retrieve that.
Probably not, no, yeah.
And in this case, this photo, this guy doesn't really, it doesn't add that much semantic value.
Right,
to that.
right, yeah.
But I mean, let's say, I have a research paper and I have a comparison table, like 2 bar charts. So I write my stuff, then I write some formula in LaTeX, and then below that I say, refer to the results in this comparison table below. So in that case, will that be packaged with the above content because they're semantically relevant, or it's excluded in the chunking process?
Sorry, so if you query your database and you ask it about the tables.
Yeah, and not just tables, any question in general, right? Let's say I have like a performance between like 2 companies, for example, for some reason in my paper. And then I say, is there any data related to the performance? Ideally, it has to look at the text above and below also, right? And if it's grouped together, it has to be served together when I do the retrieval.
Right. But the images aren't ever going to be chunked with the text, and the text descriptions of the images aren't ever going to be chunked with the text. But the text descriptions of tables should theoretically recognize that they're a comparison between 2 companies, especially if the table has like any sort of like legend text in it that's identifying what the tables are representing. Then you should also be retrieving the text description of the table and any text description around it that's relevant to the query that you have. Like, it wouldn't retrieve the table automatically just because the text around it is relevant, if that makes sense. But the table itself would need to also have some indication of relevance.
Okay. Like I was asking this because usually, let's say if I write my original document in LaTeX or Markdown, and then I export it to PDF and I submit somewhere, usually bunch of times all the charts are just images. But let's say I write the document in Word or some other format, and then I export it to PDF. Usually the chart is not an image straight away, right, when it's exported to PDF actual object. So in that case, if let's say the original source of the document is Markdown, the images have a high chance of being ignored, right?
When you export it to PDF?
Yes.
Yeah, yes, but because you don't have a markdown representation of the images, right? If you're exporting the markdown to PDF, there's no image representation in that export. And Docling doesn't support export to PDF regardless. Yeah, I don't know how you would represent the image in your markdown, if that's what you were wondering.
So what I'm trying to say is, let's say I have some developer documentation. Usually I write it in Markdown.
Okay.
And then let's say I have Mermaid.js, right? So Mermaid.js, like some browsers support, like some software support display of Mermaid, but usually what we have to do is export it to a diagram, then put an exclamation mark and the image path. And then when I export that Markdown, the flowchart's always going to be an image. It's not going to be an actual object which is in PDF. File, right? So in that cases, those images have a chance of being lost. So, we have to exclusively take care that, those kind of documents, we have to have a separate pipeline or some other process, right?
Could you just not export the whole document as a scan document?
I can, I suppose.
Like, if you don't need to preserve the markdown text, then just export the whole page as a scan. I don't know. we seem to be getting slightly off topic, but it's a interesting conversation. Okay, quickly. Okay, so we processed all the images, including the image descriptions. We can see that this is just displaying a couple of the image descriptions, right? Here's some text chunks, here's some image chunks. Each image chunk has an AI-generated picture description, right? Image blah, 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 blah. Okay, right. So we're just making sure that what we have just done is accurate, right? We've taken all these text chunks, and now we have images with image descriptions. And now we're actually going to create our visual grounding function. All this function does is take the chunk that you retrieve, pull out the relevant metadata for the actual drawing of the bounding box, and then display the bounding box. It's a little bit long because, again, the metadata that's stored for the images versus the metadata that's stored for the text was slightly different, so it has to handle those separately. But it's just taking bounding box information out of the metadata for each chunk and displaying it, right? So you feed in a chunk, it gives you the bounding box drawn onto the image. Okay. Now we populate the vector database. We're using Milvus for our vector database. So we've already created all our chunks. All we have to do is actually embed every single one of our chunks. We add our documents to the database. Now we see there's 73 text chunks, 1 table chunk, and 54 image descriptions. Now we can actually just test the retrieval to make sure that all of our documents made it into the vector DB. We'll ask the query, how much was spent on food distribution relative to the amount of food distributed? Seems like something that the Midwest Food Bank should be able to answer. When we actually do that retrieval, actually for now, it doesn't really matter what it retrieved. We just need to know that it's retrieving something, which tells us that our chunks have made it into the vector DB, right? So we can see it's retrieved text chunk, AI generated image description, some text, whatever, right? So this is retrieved, let's see, four relevant chunks. Later, we're going to set our top K to 5, so it retrieves the 5 most relevant chunks. But this is just showing that the retrieval is working and our vector DB is now populated. Okay, so now we actually are going to create our entire RAG pipeline. So here we're using LangChain to create the RAG pipeline. Essentially, right, what it's going to do, it's going to take your query, retrieve the relevant chunks out of the vector DB, the top 5, because we set our top K equal to 5, retrieve the top 5 most relevant chunks out of the vector database, take each chunk and visualize it using that visual grounding function from before, right? Take each chunk, extract the locational metadata, visualize where it's coming from on the document, and then feed each chunk to your large language model to generate a response using those chunks as context. That's the premise of all what is being built right here. This is just all building out a RAG pipeline that does all of those little steps. From there, we can actually try that query once more using our full RAG pipeline. So the question was, how much was spent compared to the amount of food distributed? So when we look at that query, it's retrieved 5 relevant chunks. Let's see what it's retrieved. So here is the part where visual grounding comes in, right? So here we can see the first result was some kind of text chunk. It seems to have retrieved the text out of this chart separately, so that's not super relevant to us. It does say value of food distributed, and then I guess some dates here, not the greatest. Let's see, the second chunk, it's a good thing we got 5. It's a text chunk again. Oh, wait. Oh, this is an AI-generated image description. And then here, text preview. This image is a graphical representation of the data related to food distribution and spending. It consists of 2 main sections. On the left side, it reads blah, blah, blah. Let's see. Okay. 13 million spent, yields $383 million. Okay, so this is actually exactly what it needed to retrieve, right? So it's found that the information was in some image, but not only does it recognize that it's in some image, but it can also show us exactly where that image is coming from so that we can go back and verify for ourselves that it's actually understood the image correctly, right? So a lot of the times, well, without visual grounding, you'd be kind of blindly assuming that your document has understood the image correctly or has converted that image to text correctly. Here, with visual grounding, we can be given the specific text, the specific image that it's coming from, and we can go back and verify, okay, 13 million spent yields $383 million worth of food distributed. That should answer the question. So if we go actually down to where the response is being generated, according to the image, $13 million was spent, yield $383 million worth of food distributed. This implies for every dollar spent, 300. Okay, well, it's bad at math, obviously, but it's not about the math part. The important part was that it recognized according to the image, 13 million was spent to yield $383 million worth of food distributed. You can just ignore all of that. LLMs are going to be bad at math. Not even Docling can fix that. But the thing to show here, right, is that if you have a document that's going to be image heavy, if you have a document that's going to have complex structure, Docling is able to recognize that structure, but also feed you back what it's seeing so that you can go back and verify that Docling's extraction was correct. But yeah, that is actually it for Lab 3, so we have plenty of time for questions now. Are there, one last thing actually, don't ask questions yet. If you want to get involved in Docling, there is a GitHub repo for Docling, there's also a Discord for Docling, and there's also a mailing list for Docling. We're having our first Docling office hours actually this Friday. And you can go on the Docling LinkedIn page. There will be, it's not linked here, and I actually am realizing now that I'm pretty sure that that link is incorrect. This mailing community meeting link is not the right mailing list. But if you go on the Docling LinkedIn page, just go on LinkedIn, look up Docling. It should be the first result. There is a post about the Docling office hours. We will actually have the full Docling technical team giving you a brief overview of the latest features as well as the planned upcoming features. The IBM CIO team will also be giving a brief outline of how they have actually very recently finished integrating Docling into the Ask IBM service to ingest a bunch of PDF information that was previously inaccessible from Ask IBM. And then there'll be time for like questions and discussions afterwards. So definitely go check that out. Definitely go check out the Docling LinkedIn or the Docling website, which is just docling.ai. There also should be a banner there that'll link you directly to the LinkedIn post about the mailing list. Okay, now I'm ready for questions. Go ahead.
If we were receiving, like, private data on forms or anything, is there any kind of, does this get read into anything?
Yeah, so that's one of the main benefits of Docling. So there are a lot of services that do document conversion. I know Azure offers one, AWS offers one. The downside to both of those is that you are having to send your data to a service and get it back, right? Because Docling is open source and also lightweight, you can run it all locally, so none of your data would leave your premises if you were running it all locally. There will be soon a hosted Docling service that will be available to customers, but I mean, you don't have to rely on that at all. It's all open source, so anything that you would need, you should be able to run on your own device.
Okay.
Yeah, and yeah, it doesn't communicate with any models. In the Lab 3 that we did, it's going to communicate to an external service, but that's only because we didn't want to wait for it to run on our own devices.
Right.
Yeah.
But you can download it and run it.
Yeah, exactly. Any other questions?
So it looks like for Lab 3 to run, you need to buy some credits on Replicate.
So you can, there should be a link that gets you like 50 cents of free credits, which is a good amount of credits. I think after presenting this lab like 2 or 3 times, it only used like 5 cents. So it's a fair amount of credit. But there is also the version available with LM Studio that you can run locally, and you just have to download LM Studio as well as the models. But that would also depend on your own device and how quickly it can run. But yeah.
For those who have never
Did I
done
just use
this
the
before,
credits?
used Docling before, but no Python, is it hard, is
spend
it really hard to learn how to create our, do our own coding on this, or does it take a long time to learn all that?
No, I mean, in my opinion, it's relatively simple in terms of, because at a base level, its functions are pretty simple, right? It does really focus on just a couple things that it does well. There are a lot of examples, so if you go on the Docling GitHub page, there's like a website, and there's a ton of examples on like all the different features. I haven't talked about all the features, but there's a lot of other features that Docling has, but there's a bunch of code examples there for all the features, and you should just be able to like copy paste them or run them in Colab. But they generally reasonably straightforward to follow through. And then yeah, the tutorials, there's several tutorials available as well, like this workshop that just kind of go through some of the basics.
Can you vibe code it?
I don't see why not.
Okay.
Yeah,
I mean.
it's trying to do it here.
I might do that.
Oh.
Can you what?
So, can you explain what you mean by conversion? You know, I asked a question before about font and font size, bold, and bounding boxes, really. I just want the raw data. I don't need it in a format like that, I just need it in a clear format. And I really need to know differences between minor font or bold, same size characters. So is there I'm playing with AI here to implement it into a project that's already using PDF Plumber and Azure Document, and there's a gap in both of those, what I want to do. And it's showing me, although it's not working yet, X0, X1, Y0, Y1 is bold, font, you know, it's showing me that it's expecting to get that data. Is that correct, or is this thing hallucinating?
So it's expecting to get like font information from.
Font size, font name is bold, is from image also, like, is it a scan, is it like those are the things that it thinks it's gonna get from me.
So Docling isn't going to be able to get any font information from a scanned document. An unscanned document might preserve font information just within its own metadata, like a PDF that is not a scanned PDF.
Searchable.
Right, it may have font information stored with it, but that's not something that Docling recognizes at all. It can use OCR to like compare sizes of fonts to recognize headers, but it's not necessarily going to say like, you know, this is Times New Roman, this is Comic Sans, or whatever it is. That would be.
It won't give you a size?
Not, like, it wouldn't be stored as size information.
Okay, so when you said converted, was that like a final stage or something in before that, or is that just the whole process is conversion?
Well, it converts to Docling document format, and then you export it into the other formats that you would want. So, like, you can describe that as a conversion all the way through, but it's more like a conversion than an export.
But there's no different raw data available at that earlier stage?
The raw data is going to be that Docling document, or raw data is going to be that Docling document format. That's going to be the most, like, that's going to be the richest representation of the document. From there, any export that you do is going to lose some of the information. But even the Docling document format is not going to store any font information.
Okay.
Going back to the, I think, question that was asked about like sensitive data, is there a way in which Docling is able to remove that data, for instance, like with PHI, if you know it's like names and dates, or is that something that you have to do like on your own?
Yeah, you would have to implement that separately. There's not like a specific model within Docling that recognizes PII. But Docling theory makes it easier to do because it can extract the text and you can feed the text directly into a simple model. But yeah.
Is this part of
not built?
Other cases
Anything
with
else?
multi-lines?
Is it, wait, can you tell us about the structure of the project? Is it part of IBM or are you an independent group?
So it was a project that was created in IBM Research, but it was then open source and donated to the Linux Foundation. So technically the governance now is under the Linux Foundation. That being said, most of the people, they're the all of the people that are primary contributors and primary members of the governing body are IBM researchers. But theoretically, in the next couple of months, either that will change as usage grows for it. But that's what we're doing here, is trying to grow usage. So if you're particularly interested, you know, always open to contributions.
Expensive, but the service I'm using is $1.50.
So here, when you're pushing the documents to Milvus DB, you're also showing the metadata, right? Of which bounding box it's part of, and also from which page it is taken from the chunk. You're showing that also, right, as metadata?
It's, yes. Sorry, it's not going into the Milvus database, though.
Sorry, what I wanted to ask was, let's say, I think in this there are the 126 documents, right? Basically 126 chunks, including all the images and tables. So as metadata, you're also showing the bounding box, and then also the page and other details, right, in Milvus as well?
Mm-hmm. Oh, wait. Sorry, are we storing the metadata? Is the metadata being embedded into Milvus as well? I'm gonna be honest with you, I don't believe so. Let me double check that. I don't believe so. I believe that when it's retrieving, it's referencing the metadata, but let me double check to confirm that. I don't want to lie to you. But was there another question? I can check that.
How can someone contribute to this project? What is,
Well, I would say join the community meeting on Friday. It's at 10 a.m. Eastern. It's just an hour long, but at the end of it, after people give their little talks, we'll talk about contributing and how to join. But I mean, always like with open source projects, just starting off with something small and just building building connections within the communities. Great. Okay, I think that is it for questions. If there's nothing else, that is it for Docling. I will see if I can answer your question really quickly soon, but thank you very much.
Thank you.
Thank you.
Thank you.